Hello, in this video we are going to work on Lab 303 question number 2. So let's go there. We have been given a problem statement. We need to go through this problem statement and construct a star schema or the database diagram, just like we did in the first question. So a very good way to do star schema diagram is to go through answering these questions like we did in question 1, thinking about what are the dimensions, identifying all the measures, and the fact. The problem reads that you have to make a star schema for a data mart for a business that sells products online and over the phone. Now the data mart should have measures of sales for items each salesperson sells to its customers. So the problem is framed in such a way that it gives us hints to what measures we have. So one of the measures we are going to have is sales for the items. So I can indicate that one of the measures is going to be sales. The data type for sales would be money. I'm just making my notes on the side, so when I go to making the ER diagram, this will be helpful. If you find making your notes on a piece of paper or pen, you can do that too. Now, to track their sales, they need to maintain information on the product being sold. So possibly, product is a dimension. Then the salesperson selling the product. So they also need information about the salesperson and the customer who purchased the product, location where the product is shipped to, and the date when the product is sold. So it looks like our dimension are going to be the product, the salesperson, the customer, the location where the product is being shipped to, and date or time. Okay, so we need 5 different dimensions. As we'll go through this, we need to identify if we can identify the attributes of each of these dimensions. So each product attributes includes its description and category. So I'm gonna underline this as text. Each location includes attributes for name, population, and average income. And customer name and address are going to be there for the customer. And for any other dimension table, include at least 2 appropriate attributes. So if it's not given, we need to have at least 2 appropriate attributes. And it says identify all the primary keys, which we will do, as well as indicate the foreign keys and the data types of all these fields. So let's go ahead and make the database diagram. In front of me, I have the same file from previous in apps.diagrams.net, and I can click on this plus icon to start a new worksheet. This one I'm going to rename as retail store sales and rename this. Now I have an open canvas in front of me. I can start by drawing all the tables that we suggested. The first was going to be the product table, and we have to have the description and category. So no primary key is given. It is usually recommended to have an integer primary key. Let's make product ID as the primary key of this table. So I start with a new table, call it dim product. And the primary key I'm going to call is product ID. And I need to indicate that this is a primary key, and also the data type of primary keys. If we are making primary keys up, usually we want them to be integers, so it's good for comparisons and queries. So let's call it integer and indicate that this is the primary key. Other fields that we were supposed to have are product description and product category. So _description, and we will just make it, it's a text variable, so make it varchar25. The next one we are going to call it product _ category. So product _ cat or category as you wish. And this one again we are going to make it varchar25. The next table we have to make is the salesperson table, and this table didn't say what the attributes were, but we have to make at least two. So let's go with the salesperson ID and their name. So let's go ahead and make that. Start with a new table. I'm going to call it salesperson. So dim underscore salesperson. And then add the first field as salesperson ID. And I am going to indicate that this is an integer field and that this is the primary key of this table. The next field can be salesperson name. So let's say sales underscore first NAME, and this we can have as varchar 25. Then if we have the first name, we'll also have the last name, sales underscore L name, and I'm starting it with sales, so we know this is in the salesperson table, and also to differentiate this from the customers table, and varchar 25. So these are the fields. Just to keep things consistent, let me modify the name so this looks a little bit better. Salesperson table. Now the next one we have is the customer table, and we must have the customer's name and address, and to indicate primary keys we can also have a customer ID. So let's go ahead and use that table. So I'm going to have one here called dim underscore customer. As a primary key, I'm going to have a field cust underscore ID, which is going to be integer type and is the primary key. Other fields we need are the customer's name and address. Let's just have customer underscore F name to indicate their first names. Again, name should be varchar. For our project, we can use varchar 25. Doesn't have to be 25. If you want, you can make it everything 50, but you have to make sure whatever you use should be enough to accommodate the field that you are working with. So last name, again, I'm using the same varchar 25. Let's go ahead and add an address field here. So another way to add a row to any of these tables would be to highlight this last row. And up here you have the table options. Click on the table and it says insert a row above, insert a row below, or insert or delete a row. So let's do insert a row after. And this one we can go ahead and call it customer address. This time we know that varchar 25 may not be enough for address. Let's have varchar 50, bigger size for it. So we're done with the customer table. Now let's go ahead and create other tables. So the next table we need is the location table. So let's go ahead, go back to our entity relationship tools, make sure we get the list here. I'm going to call it location or dim location. Then I will have location underscore ID, which is going to be an integer and indicated as a primary key of this table. And then we wanted to have the location's name. So location underscore name. Again, it's a name, so let's just keep it varchar 25. I'm just keeping it generic, but sometimes your business rules will tell you if a data needs to be of a certain type, you can use that. Lock underscore population, and population can be an integer. Then if we have to add more rows, I'll go up here, say insert row after. This one I'm going to call it location underscore average income. Again, this could be an integer field. I'm just going to move it down here. And finally, we need a time variable to keep track of date or time. So what you could do is go back to the one that you created earlier, a time dimension. Like I said, you can reuse it later on. So I'm just going to copy and paste from there. Let's make our fact table. So since this is a retail store data for sales, I'm going to call it fact underscore sales. That's my fact table. Now, since for this table, the fact table, the granularity is the sales figure for each of the sale. And we know that for each sales made, the product, what was the product sold, what date or time it was sold, who was the salesperson involved in the sales, who was the customer, what was the location for the product, where the product was going to. All of these things are important. All of these things will uniquely together identify the sale that was done. So we will have 1, 2, 3, 4, 5 attributes together forming the primary key. And again, like we discussed before, each one of them will be connecting to their original dimension table, so they will be serving as primary key or the part of the primary key as well as foreign key in the fact sales table. So let's start with one of them. I'm going to start with product ID. In this table as well, it's going to be integer because it was integer in this table. So whenever you are using foreign keys, then it needs to be exactly same data type as it was in its own dimension table. In this case, this is going to be the primary key as well as foreign key. I said primary key, but what I really mean is part of the primary key. Then I'm going to take sales person ID. Same thing, it was integer in its original table or the dimension table, hence it will be integer here. It is part of the primary key as well as a foreign key. If you need to increase the size of the table, the width, you can do that. Go to the next one, customer ID. So customer underscore ID. For the sake of keeping the video short, I'm going to pause here and complete this. So we did all the primary keys and foreign keys together. So my primary key is having 5 attributes here, which are connecting it to the dimension table. So they are also serving as foreign keys. The measures, as we noted before, in this particular problem statement was the sales, and sales is a currency or money variable. So let's go ahead and indicate that as our last field for this table, sales, and I'm indicating that as a money variable. I don't need the last row, so I can click on it, go to the table, and delete this row. Now we need to connect these tables together. So the type of relationship that's most common in data warehouse tables is one-to-many. That's the symbol of what it looks like. So let's drag the symbol. The way this works is so each row in the dimension table can be connected to one or many rows in the fact tables. That's why the symbol on the dimension table side is 1, 1, and the symbol on the fact table side is 1, many. So let's go ahead and connect them with like this. And I can do multiple instances or just copy paste, whichever looks good to you. I can copy this one, paste it multiple times, and then go ahead and work with them such that the 1, 1 symbol or the 2 lines goes to the dimension table side, and the one with the crow's foot goes to the fact table side. If it doesn't look good, then you can just use this line to make this connector as a straight connector or orthogonal connector. So whichever makes it look good, I'm going to use a straight connector. Just make sure you are indicating the type of relationship correctly. And select this line again, make it a straight connector. So now that's my diagram. Before I take a snip of it, I may like to hide the grid lines. For that, you need to go under view, and then here's the grid, hide the grid so the picture looks a little bit cleaner. Open a snipping tool and take a snip of it.